Okay, so we're going to use this idea of carbon dating. They mention in the book radiocarbon dating. Usually we just say carbon dating. So back when they found the Dead Sea Scrolls, I think it was in the 1940s, they said, oh, these are these old papers. We want to figure out how old they are. And they were able to use carbon dating to do that. Now, carbon dating, it explains a little more in your textbook. I won't get into the science of it, but you can read it in there. It explains a little bit. I think it's only good for something that's up to like 60,000 years, 80,000 years old. It's not good for really super old things, but within that time frame, it's fairly accurate. Okay, so it has to do with how much carbon-14 is left in the specimen you have, okay? So in example 3, it says a bone fragment is found that contains 20% of its original carbon-14. To the nearest year, how old is the bone? So now we're trying to figure out how old this bone is. This 20%, that has to do with that ratio A over A naught. So that's how much you have left. There, it had an original amount, and now there's only 20% of it left, okay? So this will be the R, and the R is going to be 0.20. Now, this refers to the formula that we had in the last video. T equals the natural log of R over negative 0.000121, just no T, just 121. Okay, so now that we know 20% is what we have left, we know what the R is, so we can figure this out. So time is going to be equal to the natural log of 0.20 over negative 0.000121, and we're going to put that in our calculator and see what we get. Remember, when we put in the natural log, it opens the parenthesis, and you have to close that parenthesis before you hit the division. Your calculator won't know what you mean otherwise. And I am getting it to be about 13,301 years old. So the bone is about 13,301 years old. So I'll just round to the nearest year. It says to the nearest year, how old is the bone? Okay.